Hey, what's good, everybody? Guys, welcome to another episode on the Incredible Academics YouTube channel. So, we are going to be looking at compound angular identities. So, remember the thing that we covered in the previous video. So, this is just a continuation. So, right, so this is just a continuation. So, I'm just going to do a quick recap so that you guys can have a clue what we discussed last time. So the first identity, right? The first identity, the cosine of alpha minus beta. This is literally what we proved. Okay, this is what we proved. So what are the characteristics of this compound angular identity? Right. One thing I'd say is that the ratios are the same. Remember, the first thing that you're going to do is you're going to say, okay, if it's a minus, say, are we going to have a plus in between the expressions or a minus? Minus goes with plus for cos. Okay. So and then we know that there's going to be an expression that goes there, and then another expression that goes over there, like a product of two trig ratios. Okay, so it's either that product consists of trig ratios that are the same or trig ratios that are different. Okay, but with cosine we know that the trig ratios are going to be the same. In other words, we won't have cos, okay, and this side we're going to have sine, and then we figure out the arrangement of the angles. Now with the angles, it's pretty simple. We're just going to have alpha here and then beta here, also alpha here, beta here. So the angle is quite straightforward when you're dealing with cosine, but you must be careful when you're dealing with sine. Okay, number two is also quite straightforward because it's just a duplicate of whatever that's up there. We're just changing the sign. So the cosine of alpha plus beta is going to be exactly what's up there. So cosine of alpha, cosine of beta, and then minus. Because it's plus there, here it becomes minus. So minus the sine of alpha, the sine of beta, and that's that. And then number three, now we're switching trig ratios now. Now we're looking at the sine of alpha minus beta. Okay, and the first thing that we're going to do, we're going to figure out the sign that's going to be in the middle. All right, and the sign is going to be what? Minus. With sign, we don't swap things around. If it's minus there, even here it's going to be minus. Cool. So now another question is, okay, remember we're going to have a product of two trig ratios here. Product of two trig ratios. The question is, are we going to have the product of trig ratios that are the same or trig ratios that are different? Remember with cosine we had trig ratios that are the same. Cos, right? Sine. So but this time around when we're dealing with sine, the trig ratios are not the same. So in other words, you're going to have sine over there and then cosine. Okay. Again, you're going to have sine and then cosine. Now we need to arrange the angles. Okay. So with the first product, we just maintain the order here. We start with alpha and then the beta. So alpha there and then beta there. But this side will swap the order around. So beta comes here, alpha goes there. Are you guys with me? Yeah, so that's the trick about sine, that you need to, on the second part, you need to swap the angles around. Okay, but with cosine, pretty straightforward. So number four, so obviously it's going to be sine of alpha plus beta, which is a duplicate of whatever that's up there. So sine of alpha, cosine of beta, and then plus. Because it's plus there, you're going to have a plus sign there also. Sine of beta, cosine of alpha, and there you have it, ladies and gentlemen. We've got the compound angular identities. Okay, it's just 4 of them. All right, and these are going to be sort of like used in conjunction with the double angle identities, the square angle identities, so on and so forth. The tan, identity as well. Tan theta is cos to sin theta over cos theta. Those kind of identities, that everything is going to come together now. All right, everything that you did from grade 10, 11, and 12. All right, cool. So the question that I want us to quickly look at is this. So expand, all right, expand using the compound, right? The compound angle identities. All right, so this is the question that we've been asked. So, and then the expression that we're going to look at, the first one, the sine of x plus 20 degrees. Okay, please don't neglect the degrees over there. So sine of x plus 20 degrees, that's equal to what? So we're going to say, okay, what's going to be the sign in the middle, right? Remember, we're dealing with sine here. Whatever that's there, you just keep it there as well. And then we're going to have two products here, okay, of two trig ratios. Now the question is, okay, are the trig ratios going to be identical or different? It's sine, so they're going to be different. So we're going to have sine, cosine, sine, cosine. Now plug in the angles. With the first product, we don't change the order here. We start with the x and then the 20 degrees. So x here, 20 degrees there. But the second product, we swap the angles around. So 20 degrees there and then x there. Right, guys, come on. This is not that complicated. So, okay. Second problem. So the cosine of 2x plus 10 degrees. All right. So the first thing that we're going to do, all right, the middle sign. It's plus over there. So we're going to have what? Minus. And then we figure out what products are going to be there. Okay. So remember, we're dealing with cosine. Our cosine, the trig ratios are going to be the same. So we're going to have cos. We're going to have this side sine, sine. And then we plug in the angles. Remember, with cosine, we don't have to swap around the angles. So it's all done. Cosine is not complicated, y'all. Yeah. So let's look at C. Right. I'm just trying to look what problem I can actually tackle, but okay, let's look at let's just say our C is going to be the sine of 2p minus q. Okay, yes, the sine of 2p minus q. So let's simplify that. Okay, it's sine, so minus. Now let's figure out what's going to be here. Remember what I said, with sine, the trig ratios are going to be different. So we're going to have sine, cosine, sine, cosine. Cool. Now we just plug in the angles. Here we're going to have 2p, here we're going to have q. But this side, we'll swap the angles around. So q comes here and 2p goes over there. Okay, that's that, ladies and gentlemen. And let's just see what else we can do. I'm just gonna do one more, and yeah, I'm sure you guys will be very much comfortable with these things after that. So let's see. So let's have cosine this time around. So the cosine of 2p minus 40 degrees. Okay, I hope you guys can see that. Yes. Okay, remember, with cosine we focus on the middle sign. That's the first thing that we're going to do. So the middle sign plus. All right, and then now figure out what product was going to be there, or also what product is going to go there. So cosine, we're going to have the same trig ratio, so cosine, sine, sine. All right, now we arrange the angles. Remember, with cosine, angles are not a problem. We're not swapping anything around. So 2p, 40 degrees, and then also 2p, 40 degrees. We're not changing anything. There we go. All right, the expansion is done. So let's look at something that's slightly different. Okay, slightly different. So now the question is, use the compound angle identities. Angle identities to simplify each expression. Simplify each expression. Okay, so that's the question that we have over there, right? That's the question that we have. So we're just going to seems like I'm running out of battery. Yeah, but let's just so let's just close it off right here. So next time when we meet, we're gonna focus on this one. All right, using compound angle identities to simplify expressions. So that is fine. Until next time, let's go.